So in this video, we're going to take another look at construction and destruction from a slightly different angle before we move on and talk about some of the other special member functions. So let's take a look at what happens with construction and destruction at different kinds of objects: local objects, global objects, and heap objects. Okay, so there are three main regions of memory, just to jog your memory, right? There is the stack, where we have locally declared variables. There's the global data section, where we place our global variables, global data. And then there's the heap, where we have anything that's dynamically allocated using new or malloc. And we can declare objects in any of these memory regions. And so when we do, a constructor will run to initialize them. And then when those objects are deallocated, the destructor runs to indicate or to clean up after the fact. And depending on where this object is, these things happen in slightly different ways and at slightly different times. And it's just worth kind of seeing that happen in action to get you thinking more about it and how these objects really work and how constructors and destructors really work. So this verbose class is one that we used in a previous video, so you may recall some aspects of it. Basically, the way it works is I stick a string inside this class, and then my constructor takes a string as an argument, and then I use the argument to the constructor to initialize the string inside the object. And then we print out a message saying, whatever that string is, it's going to be the name, some sort of identifier, I'm born. And then when the object gets destroyed, we print out this message, name, I'm gone. And so if I ran this main function, then I would get something like local, I'm born, and then local, I'm gone. And I would just see those two things back to back. Now I'm going to embellish this a little bit, and I'm going to add a global variable. And so I'm calling the variable itself as global, and then the constructor is taking this string global in quotes as its argument, so that when I print that to the screen, I'm printing the name of the object that I declared here. And that way we can kind of map things up to each other. Likewise, I still have my local object that has the string local inside of it. And then I have a heap object where I put the string heap in. And remember, for heap objects, I'm going to use new and to declare it on the heap. And because I'm creating this region on the heap, it returns a pointer. And so really, this heap variable that I declared here is actually a verbose pointer, not an actual object, just a pointer to an object. But this location on the heap is a real object. Okay, okay, so what happens when I run this main? And also notice that I have these cout statements where I'm printing where main starts and where main ends. So what's going to happen first is that before main ever starts running, my global variable gets constructed. So that's kind of interesting, right? Because in C code, we always think of it as starting at main. But now with C++ code, we can make things happen before main. If we have a global object and we place code in its default constructor or in any constructor, that code runs before main even starts. And so here I see this announcement of the global saying, I'm born. And that makes sense because a global variable is supposed to get set up before main starts running, because main could use the global on its first line of code, right? So whatever's needed to get that global all set up and ready has to happen before main. But then the interesting thing is global is also the last thing to go. It's the last thing that prints I'm gone. And it's because that global lives the duration of the whole program. And it's not until the program ends that global gets deallocated and that we then call its destructor. But it's kind of a neat thing that we do call its destructor at the very end of the program after main has finished. So this global lets us actually do things before main starts and after main ends. So the local variable in here, it's declared after this print statement that says start main. So actually we see that after we print start main, we see the local declare that it's born. Okay, then the next line of code, we create the object on the heap. And so after local I'm born, we see heap I'm born. Okay, and then after the heap object, we print out that main is ending, right? And then main ends. And when main ends, it deallocates its stack. And when we do that in C++, we also run the destructor of any object that's on the local stack to take any actions that need to be taken to clean it up. And here, we print out local I'm gone. Okay, and then, as we already talked about, the last thing to go is the global, and it prints out, I'm gone. Now, one thing to note here is that the heap object never printed out I'm gone. And that's because anything we put on the heap, it stays on the heap until we explicitly delete it. And in this code, we never explicitly deleted it. And so its destructor never ran. And it basically survived even longer than global and stayed in memory to the end. Now, don't get worried. This heap object isn't still in my computer's memory somewhere. When a program ends, the operating system eventually cleans up all the memory associated with it anyway. So yes, it did eventually die, but its destructor never executed. If I add a delete call here to free that heap object, now remember, anytime I call new, I need to pair it with delete. And so when I put this delete statement here, then this is going to trigger the destructor to get called. And now when I look at the new output of this program, then right after we call heap I'm born, then we also call heap I'm gone gets triggered and its destructor runs. Okay, and everything else stays exactly the same because we didn't change any other code. Just a reminder, you got to call delete to get rid of those objects. But globals, you can reliably count on them being constructed at the very beginning of the program before main starts and getting destructed at the end of the program before it finishes, before the whole program finishes, but after main. And locals, they get constructed wherever they are in their function, like wherever they fall, they get constructed, and then they get destructed as the last thing before that stack gets popped and before the function returns. Heap objects get constructed when you call new, and they don't get destructed until you call delete. And if you never call delete, they stay in memory forever and they never get destructed at all. By the way, when that happens, that's called a memory leak. And generally speaking, we don't want memory leaks, although for short programs, it's irrelevant because they won't cause any problems. But for long-running programs like servers, if you have lots of memory leaks, eventually you run out of memory and the server crashes. So memory leaks are not good, and it's always good to avoid them. But for small example programs, they're not really a big concern, but you should always strive not to have a memory leak. Okay, so in summary, global variables are constructed before main ever runs. That's pretty cool. We can make things happen before main now. Locals are constructed where declared relative to other objects and statements. Local and global variables will run their destructors automatically when they leave scope. The programmer is responsible for deleting heap objects. Don't forget delete. Or they remain in memory until deleted.